Hello, everyone. My name is Samiha Marwan. Today I'll be presenting my work, which was in a collaboration with Anay Dombey, who was a research intern in our lab, and my supervisor, Dr. Thomas Price. So today I'll be talking about unproductive help-seeking in programming, what it is, and how to address it. And what I mean by help-seeking is that when students are seeking feedback from instructors or programming environments. And as you all may know that in education, there's lots of work that shows that feedback is essential to improve students' knowledge and learning. But this feedback traditionally comes from instructors. And with the growing enrollment in computer science classes, researchers developed programming environments to provide this automated feedback to students to give them better support. However, novices often lack the ability to effectively seek help, like they don't know how to seek it in a good way. For example, some students may just avoid it even when they need it. Maybe they just are not aware that it exists. Other students may just abuse it, like clicking or asking for hints many times because they don't want to put in effort in this. And both of these behaviors represent unproductive help seeking, which can embed learning, and therefore the feedback will be ineffective. So my goals for this paper is that we hypothesize that if we're able to improve students' help seeking, then we'll be able to improve the effectiveness of the feedback. And therefore, we'll be able to improve students' learning, which is actually the main purpose of having this automated feedback. But before thinking about how can we improve help seeking, we need first to understand what are the specific forms of unproductive help seeking that novices do when they are programming. So this led to our first study. In our first study, we proposed a taxonomy of unproductive help-seeking in programming by analyzing students' data while they are doing their homeworks, their programming homeworks in real classroom. So I'll not go into details about the details of the subcategories of the unproductive help-seeking, but you can find it all in the paper just because of the time limit. But I want here to highlight that we found out that students' help-seeking behavior, 58% to almost 74% of it is unproductive. And this is very similar to prior work, but in a different domain. So this taxonomy was really very specific, that it can help us to understand how can we inform the design of a programming environment to avoid this behavior. And this led to our second study in this paper, our second research question in this paper, which is how can we design a help interface to improve students' help-seeking? So we designed a new interface that can provide students with help based on their performance, based on their progress over time, like if they need it or they don't need the help. So it is not on demand where students can just ask for hints at any time, and at the same time it's not proactive where we can give them hints without any control if, for example, they did a given number of errors. So in order to do this display, it has two steps. First, pre-processing of historical students' data and a way to measure students' progress in real time. And I call it data-driven because it's based on previous students' data. So imagine that this is an example of a prior student solution. So we defined a set of objectives for these solutions. And then we implemented an autograder to detect the completion of each of these objectives. And then we computed the average time taken by prior students to finish each of these objectives. For example, we found out that one objective, prior students finished this one objective in an average time of 2.34 minutes. And prior students finished two objectives in an average time of 4.13 minutes. So let's see how this actually works in the system. So this is a programming environment. It is called iSnap. It is a block-based programming environment. And here a student is working on a specific exercise. And while he is working, he might be stuck. He is not able to finish any of the objectives that we have already defined. So while he is doing that, the system is monitoring their progress using the autograders that we have defined. And so as you see here, after spending some time based on prior students' time, the system will give them a hint like this here. So this hint button, just small button, it will flash next to their code to remind them that, hey, you can get a hint. You may be in need of a hint now. And then when a student open it, if they want, they can get it. So again, it's like not really on demand because it only pop up if the student is falling behind. And at the same time, it's not proactive because students can just open it if they want. They can just ignore it if they want. So in order to understand if this interface was really helpful to students or not, we conducted a pilot study to understand its impact on students' help seeking, learning, and perceptions of the usefulness of the environment. Our population was undergrad students. They were all 30 students, 16 males and 13 females. So all students were given hints, but half of them were randomly assigned to have the data-driven display and the other half to on-demand display. And then they took a pre-survey, a tutorial on iSnap, and then they took the first task, which was with hints and for 15 minutes. And then they took the post-survey, and then they took a second task, but without hints. And the reason for this is that we want to understand how much the hints that were given to students in the first task help students or students learned from it that this thing was transferred to the second task without hints, so that they can use the benefits of the hints they have received in the first task to the second task. So which we call learning transfer. And then at the end, they have the second survey, and actually both surveys just to understand students' experience and their perceptions about the whole programming environment. And the data was students' log data and surveys. So our first sub-research question is that what is the impact of the D-display on the students' help seeking? And we found actually that the D-display, only 4 out of 15 students has unproductive help seeking behavior, and only 10 out of 15 students in the on-demand condition has unproductive help seeking behavior. So you can see the big differences. However, they were not significant because of the small sample size. The second thing is that we want to measure the performance, and we measure performance on learning by measuring the time taken to complete a task. And what we found is that in the data-driven display, it helps students less when they are using the hint, like in the first task, but it helped them more on the later problems, which was more challenging and it doesn't have hints. So in order to understand more this outcome, we checked the students' hint usage, like how many hints they have received and their process time. And we found out that students in the data-driven display, they opened significantly more hints and they view it for significantly more time than the on-demand condition. So these results showed that maybe providing hints at a time when students really need them, it allowed them to process hints better, which affected their performance in future tasks. And we argue that larger studies is needed to confirm these results. And then we wanted to understand students' perceptions of the helpfulness of the hint display, because we thought that maybe because they don't have control, then they will be distracted or bothered by this programming environment. But actually we found no evidence that the data-driven hint display was perceived as less helpful than the on-demand design. Also, when we asked students why you give these ratings, we wanted to understand why, if they like it or not. We found out actually that some students noted what they have learned from the hints in the first task and how this helped them in the second task, which is really exciting. And also some students noted the intelligence of the system, where they said, for example, it seemed to let me try to figure things for a minute and they'll tell me when I couldn't get it. So it looks like they captured that they will not get hints all the time. They're just getting it only when they need it. So in summary, the purpose or the outcomes of my work is that we developed or designed a taxonomy for unproductive help seeking. And then we use this taxonomy to develop a new hint display design to improve students' help-seeking behavior. And we conducted a pilot study that shows that the new hint display could improve students' help-seeking behavior and possibly their learning without reducing the perceived usefulness of the system. This was the end. I hope you like it, and I'm ready to hear your questions. Thank you.